Okay, in the universe, there's 10 to the power of 23 stars. That's a lot of stars. And in the universe, there's only one planet that has all the conditions to have life, and that's ours. And 70% of the surface of this planet is covered with water. And ourselves, we are more than 57% in average of water. The question is very simple. Without water, there's no life. And that's where life is coming from. And that's a condition for life. You all know this. I would like to speak about pollution in the ocean. So this is millions of tons of plastic debris traveling in the ocean. So we are throwing stuff away, it breaks down, goes into the river, ends up in the ocean, and accumulates and stays there forever. The birds eat it, the fish eats it, and then it might end up in our plate, in our food. From January to April, I'm going to get on this boat and travel around all the oceans of the on the Earth, and to try to study these plastic pollutions. My family, I'm half Japanese, half French, and my family is living close to Fukushima. So last winter, I borrowed a bicycle from a friend, and I cycled from Tokyo to Sendai. And each point you see on the map is a point of measurements. The points of measurements of radioactivity that the government gives to the population is sometimes half of what the population, the local residents, are measuring. So there's a very huge need of civilian based measurements. The population needs to make their own measurements to have independent measurements. And that's what I'm going to talk about mostly is the oil spill. So I guess that's a theme of interest for Brazil because you have a huge and flourishing oil industry, which is also a very huge risk for the environment. So when the oil spill happened, I was working in MIT in Boston, and I moved to New Orleans to go and study and combat the oil spill. So I joined a kind of activist group, and we were doing oil spill mapping. So we're studying the movements of oil. So I went many times on boats on the oil spill. And we started to think of how we could clean up the oil better. These factors, oil, plastic, and radioactivity, are all man-made problems. There's no problems in the oceans big problems that we're not really responsible for. And my belief is that if we had the power to create these problems, we have to give ourselves the power to solve these problems. So I'd like to present to you the project Prote. Prote, the idea behind it is to use the natural forces to remediate the man-made problems. So in an oil spill, typically an oil spill happens and the oil drifts. We're taking this small boat and we're trying to clean the oil, but it's very inefficient. If we're using the same amount of oil boom, like an oil sponge that they're using, and you're taking a bit of care of the natural patterns of the wind, the wave, and the current, which is the forces that control the oil, then you could do a better job. You could do even better job if you multiply the layers. But it's very difficult to move so much material. So the idea is very simple. Just use a normal sailing boat and sail upwind to capture the oil that is drifting downwind, using natural forces to capture a man-made problem. So we didn't know if it was going to work. So we just took a small sailing boat and pulled something long and heavy. And what we observe is if you pull something long and heavy, you're losing two things. One is the pulling power, of course, and the second is direction. The reason is because when you're in front of the wind as well, when you're turning, you're facing the wind, and you have no more pulling power. So we thought maybe a way to improve this would be to take the rudder from the back of the boat and put it at the front. So we tried to pull something of 4 meters behind the boat of 1 meter, and the results were quite surprising. With a very small force, with a very small object, we can control a very large object. So we can use natural forces again to control cleaning material. Then I kept playing and then find out that this boat actually has much better maneuverability. It's a little less fast, but you can turn much faster and it's much more agile. So here you're going to see it's going to avoid an obstacle at the very last second. Then we kept thinking, how can we improve a normal boat so it can pull more weight? Maybe a rudder at the front and another one at the back. So we made a small boat, put a lot of electronics inside it, start to put sensors, microcontrollers, a small computer inside it, and see if it works better. So this one has a front and back rudder. But it was not working so well, so we kept thinking, maybe we can make it even better. So why, instead of having a front rudder and a back rudder, if the whole boat changes shape? So we built this one, and we tested in the water, and again, big surprise. It's absolutely, it's way superior to a normal boat, how much this boat can control in terms of pulling things behind. So this boat has completely new maneuvering capabilities. And so this is in quite high wind condition, and this is in low wind condition. So now we're going up the wind, we're making a small maneuver, and you're going to see a small movement with a low wind condition. But observe one thing. When the boat is curving, the two sails, the front sail and the back sail, are at two different angles of the wind. So you see it's making this gentle turn. And look at the position of the sail. Because the boat hull is curved, two sails are at two different angles of the wind. We can never be in front of the wind and be stuck or have no pulling power. So it means that you can pull something long and heavy all times. But then we wanted to know, okay, that's cool, but it works at small scale. Can we make it big scale? Can we make it industrial? So we make it much bigger one, inflatable. It has a very light sail surface, and it's very light. So it has a very small footprint. So potentially it's very strong, very cheap, and we can make it industrial scale. But then we wanted to know if we could automate it. So we made bigger version. We put bigger motors inside it. And the way we do it is all that I show you happened in the last year and a half, 2 years. So basically our technique is we have an idea and we prototype it very quickly and we put it in the water. For example, here we didn't have a sail yet, but we wanted to know how much we could float. But we didn't have enough weight at the bottom, so we put some cameras, some sensors on it. We put a sail, we pull the sail and see if there's no balance, there's not enough weight, we pull it out of the water, put back some weight, and come back, and we want to improve the penetration in water, we add the skin, etc., etc. We always go back and forth between the workshop. So that was in Rotterdam last summer. Oh. So the properties of this new hull are quite revolutionary. We can have a better trajectory control and better stability. We can, like I was explaining before, you can turn into the wind more efficiently. Because of the shape of the hull and a very long hull line, we create less turbulence and less resistance in the water. Interestingly, when we're hitting the wave, most boats, they're hitting the wave and they're losing a lot of speed. But our boat, because it curves, conserves a lot of speed. We are working on two different sizes. 1 meter for environmental sensing and 6 meter for transporting big sensors or transport cleaning material. The idea is to have a modular boat. The technology that we're developing mostly is in the head, in the propulsion. But behind this propulsion head, you can add many modules. In each of these modules, you could put different environmental sensors. Some could be for general oceanography, or some would measure from oil, or some could measure radioactivity. You could put different sensors in different modules at a very cheap price. The application of such technology, which is essentially a transport of sensors, are multiple. In Brazil, again, another big application could be mapping coral reefs. Most of the coral reefs are in danger, and they are also the biggest biodiversity reserves. So also you can monitor fish. There's many areas in Brazil, anywhere in the world, that are overfished because we cannot make appropriate measurements. Oh, it's very difficult to read, but these are the application of the technology. Something went wrong. But basically, it goes from oil spill cleaning to plastic sensing and collection to radioactivity sensing to transferring signal for underwater vehicles. There are many, many applications, and also safety at sea. Okay, so all this technology, usually, if it's really cool technology, all the inventors, they will patent it. But we do it in a very different way. We have a license, which is like the open source for the software, but open hardware, which means that we give everyone the right to use, modify, and distribute our technology. In exchange, we only ask two things. One, that they credit the name, the authors, our group, and the second, we ask them to contribute to our community. If they use our technology for free, then they have also to contribute back to the community that generated this technology. The idea is that if there's a technology that's good for the environment, everybody should have access to it. And instead of trying to hold a monopoly, like most industrials do, it's to create a market, not a product, but a market. To create a call to resolve environmental problems. When you want to duplicate a technology, it's like in science, you need to produce a certain number of documentation so it's duplicable, so people can improve the technology. So these are the standard we're using. This technology, I started alone in the garage, but now it's a whole community around the world developing it. It's mostly happening on the internet because we're spread out, but we're trying to meet as often as we can. And there are people in Brazil here that are interested in developing this technology that I'm going to meet tomorrow in Santos. The water is our future when it comes to food, when it comes to energy, when it comes to where we live, where we come to transport, to information, and security. Again, it's hard to read. But the big message I want to give it to you today and is also this. I'm very, very honored to be on a scene that both Ministry of the Environment and activists can speak. For me, it's one of the first time I see this happening, and I take this as a blessing. I'm very happy this is happening, and I'm thanking you for letting this happen. So I want just to give 1 minute about the political dimension of open hardware and technology. The idea of open hardware is that everybody can contribute to it. The type of research I'm doing is typically academic research. But my background is environmental activism. A few years ago, I was doing exactly like them. I was going to places and laying naked in the street in front of trucks. I've been doing that stuff for many years. What I want to say is that this is because of my family. They kind of forced me, but the idea is that open hardware technology allows environmental activists to use this technology in the field and denunciate industry or politics. But it also allows politics to come and say, okay, we want to give some money to develop this, and industry to work together to develop tools, instruments that are transparent and keep both population and the politics accountable. So, yeah, so my wish is that we keep developing together open hardware for the environment, and especially my interest is the ocean. So thank you very much for your time.